So, like I just said, we're going to start jumping into functional JavaScript. It's kind of going to take a step away from the DOM manipulation stuff for the rest of this week. But I do want to take a quick look at the coming schedule before we jump. So on the curriculum today, we are going to be doing, this guy down here, advanced functions. I know it kind of seems like we're moving around a little bit, but we're going to do advanced functions today. And then the last 3 days of this week, we have some additional content we're going to walk through together, some underscore stuff, and some other sort of functional JavaScript things. So this will be kind of the rest of this week. This will be what we do today. Other than that, like, it's going to be probably a lot of new concepts, and they take a while to wrap your head around. So if it's the first time that you've seen it, the stuff that we're talking about today and this week, like, definitely get on office hours or talk to your peers. It takes some time to get used to, so don't feel like it's mind-blowing if the first time you see it, it seems bizarre and hard to understand. So hang with us this week. I think you guys will do awesome. You'll follow right along, but just be ready to, like, use your resources and spend some time getting familiar with the concepts that we talk about today and this week. Okay, so with no further ado, we're going to actually start off with a presentation by Camilla. Hopefully, is Camilla here? Oh, yes, she is. Awesome. Camilla, are you ready to give a presentation on an unknown topic?
I have it tomorrow.
Tomorrow? Am I wrong? Who's presenting today?
I'm going today.
Oh my gosh, I misread the schedule. Awesome. I'm glad you guys are on top of it. George, are you ready to present today on, you had a topic, Scratch, right?
Yeah, that's my topic.
Wonderful. Okay, I'm going to pass it over to George.
Cool. Okay. So would everyone please go to this link? We'll do the same. Okay. Has anyone ever used Scratch before? Cool. Okay, so we've got a couple of people with Scratch. Well, hopefully in 5 minutes, since that's how long we get for our presentations, I'll be able to walk you through building a little Scratch game. People have probably played the helicopter game. That's what it was called in the 90s. Now it's called Flappy Bird. But the game is pretty much basically that you have this sprite. In our case, it's this parrot, and he goes through some sort of cave or obstacle field, and you have to get the parrot to move up or down and avoid the obstacles. So if you've never used Scratch before, there's a couple of different parts in your screen. The one on the left is clearly your application, so to speak. So you've got some sprites. I built you some initialized stuff so that we could kind of get started quickly. So our main character is this parrot guy, and the sprite list is on the bottom on the left. So you can see we've got cave 1 in red, cave 2 in blue, cave 3 in green, and our parrot. We're going to be coding our parrot. So the middle screen, this kind of column in the middle, has all of our blocks, and everyone should be blue block with motion, but we want to put an event first. So go ahead and click on events up at the top and drag out the block that says when flag clicked. That's our event. That's going to be like every code piece that we attach below that is going to run when we click that green flag that's next to the red stop sign.
Hey, George,
So
can you share your screen?
one flag clicked.
Can you share your screen too, George?
Oh, sure. Yeah, I could do that. Share my screen. Share. Okay. Is that good? Can everyone see that screen? Or
Yep, you're good. You're good. Thanks.
okay. So we're going to have this flag clicked block, and that's going to be our event. And what we want basically is we want to have, when the space bar is clicked, we want our parrot to move up, and otherwise we want our parrot to fall down so that it's always falling down due to gravity. So if you go to control, there's all of these different kinds of loops and conditionals, just like JavaScript has. So we want to pull out this if-else block here. And so our condition is in this like hexagonal piece here, and we can go down to sensing, and we can pull out a space key pressed. So now our code says when the flag is clicked, if the space key is pressed, then, and what did I say? We want to go up when the space key is pressed. So we'll go under motion category, and we'll grab a change Y, and we'll set it to 5. And otherwise, we want to change Y by -5. So that's going to create this system where when you press the spacebar, the guy's going to go up. Otherwise, he's going to come down. But one of the biggest lessons to learn in Scratch is that computers only do exactly what you tell them to do. So this is literally going to say, at the moment when the flag is clicked, we're going to evaluate all this stuff, but nothing more than that. And so in order to get the program to continuously make this program run, we want to go into control and pull out this forever block and wrap everything around there. Am I going too fast for anybody? Speak up now if I ever hold your peace, because we're going to fly through in 5 minutes. So now when you press the space bar, he falls down, but when you hold down the space bar, he goes up, right? So that's our program at the moment. So we can hit the red little button to stop our program. And now what we want to do is we want to basically create so that our parrot moves up and down vertically, but it's given the illusion that he's going through this cave by making these cave sprites move right to left across our screen. So I've already put some code into these cave sprites here that use a variable called distance travel. So if we go to our data, this is a variable I created, distance traveled. So the first thing we want to do when we click the flag is we want to set our distance traveled to 0. And then in our forever loop, we're going to change our distance traveled by, let's try 5. And now when we reconnect that, when we press the flag, you can see that our little caves are being animated across the screen. And our game sort of works right now, but it's kind of a boring game because you can't lose, and our bird looks pretty lame. And then you go past the finish line, and the game doesn't stop. So we have to code some things in order to fix the bugs in this game. So some things that we could do is, first, you'll also notice that when you click the flag to restart, our parrot is like in the dirt here. So we want to initialize the parrot to start maybe in the middle of your screen. So you can go to motion, and you can pull a go to X and XY coordinate, and we can pull that out and put that at the top. And we can tell him to go to 0, 0, the middle of our screen when you start. So when you click the flag, now he's going to go to the 0, the beginning of, like, the middle of your screen, and then you can use your flag to make your sprite move. Some other things that we might want to do, if you notice, there's 3 tabs here. There's scripts, costumes, and sounds. And costumes are like different animations that you can use for your sprite. So we've got 2 different sprites, 2 different costumes. One of them has got his wings up and one's wings down. So we can use that to make our bird give the appearance of flying. So if you go to looks, this is where you change all of the graphical effects of your sprites. So we can there's a block called switch costume. So you can throw 2 of those blocks down. So when he's flying up, you're going to switch to parrot A, and when he's flying down, you're going to switch to parrot B. So now when you're flying, he flaps. Okay. So there's 2 more things to do. One, we need to create a condition where the parrot will lose, and a condition where the parrot will win if you guys get to the end of the game. So all of our little cave sprites are all outlined in black. And so in Scratch, there's this really child-friendly sensing option, which is touching color. So you can say if our parrot is touching a particular color, then we're going to do something. So in this particular case, we're going to pull up this touching color sensing block, this blue one, and we're going to say if he's touching the color black, we're going to end our game. And in order to end our game, so we'll pull out another if block here. If the parrot is touching the color black, we want to stop all. And what we could also do is maybe change our costume, just like we changed from flapping. We can change it to this explosion so that the parrot explodes when he runs into a wall. So we can say switch costume to explosion and stop all. So now when we run our code, he runs, and if he hits the wall, he explodes, and you lose. What we haven't done is we haven't coded a condition for winning. But to do that, it's basically the same thing. So what we would want to do is we would want to code it so that when the parrot touches the color of the finish line, which is this bright green color, then you're going to code some condition to win. But I'm not very good at this game, so it's hard to get to the finish line. I teach this this programming language to kids, and a lot of times kids get into this loop where they're trying to solve a problem, but they have to play their game repetitively to get there. And the biggest advice is we'll take out the condition that causes you to lose in order to continue your game. So if you just take out that touch and color block, now you can't lose your game, and you can get all the way to the end so that you can access the color of the finish line. So when we get to the color of the finish line, you can just stop your program by hitting the red button, and now we've got this bright green color where we can add in another statement, another if statement that says if he's touching the color bright green, then we want to basically have some sort of animation or something to say you win. So we could even make the parrot say like, you win. And that is our game. How did everybody do? I know I went through about an hour's worth of programming on Scratch in about 5 minutes, but did anybody keep up?
That was awesome, George. That's great. Cool program too.
Yeah. But if I could take 30 more seconds,
yeah.
This is probably a program that, within half an hour to 45 minutes, I've been able to teach like 4th and 5th grade age groups to program. And this has got some pretty complicated, there's a lot of JavaScript concepts that are under the hood here. There's conditionals, there's variables. This is kind of like you're changing your distance traveled variable by 5 repetitively. So that's kind of like, this is a big loop here, this forever loop. But Scratch can do pretty much everything JavaScript can do. So, for instance, this is some code that we were working on with some 8th grade students, and the prompt for the class was that they were supposed to. So when you click on the flag, this little sprite asks your name, and so if I type in my name is George, it uses the variables and inserts it. Says, "Hi George, you're the best," and animates my name. But under the hood, there's a lot of stuff going on here. There's this function to make sure that when the input field is initialized to be all lowercase. And so if you read this here, it's you've got this basically an array of lowercase numbers, and then you're setting your I to 0. So this is a cut and dry for loop that I helped some 8th grade students write, and you're iterating through the length of your array, and then you're basically determining if your letter variable is equal to the letter in each index of your array. So it's kind of like a for each loop, and if so, you're going to set your letter variable to a lowercase value. And so this is a way to basically initialize your input as all lowercase so that your program can read it. And so the value of this is, I'm basically teaching 8th graders through these little blocks a for each loop, and maybe in high school or later when they see this and they're doing JavaScript and they're like, oh yeah, I've seen a for each loop in Scratch before, and they kind of understand the logic behind a for each loop or any other kind of loop or any kind of function without using any syntax or seeing any sort of scary code. And all the while they're making this cute little project that is entertaining to them. And so it's kind of this whole big, wonderful experience that the students get. That's my spiel.
Cool. Thank you, George.
All right. I'm going to stop sharing my screen here.
Cool. Awesome. Scratch is super fun. All right. So on to our topic for today. If you missed the intro, we're going to be starting to talk about higher order functions. Let me share my screen. First thing, let me get a quick thing here.
I'm just reading the the group chat right now, and I'm seeing the cheat code that allows you to remove the lose element, and it's probably something along that lines. I don't really know how those work, but Game Shark or something probably edits the initial code somehow.
It was all so simple all along, all those hours we spent trying to beat those. Okay. Oops. Week 3, day 2. Cool. So first thing we're going to talk about is functions that take other functions as parameters. So, oops, script.js. Close this one. So we're going to start by looking at a built-in JavaScript function called setInterval. This is on the MDN page. This would be obviously a good place to go when you're going to use a function you've never used before. If it was the first time that you were being asked to use something like setInterval, probably worth like going to MDN and like reading through this like fairly thoroughly, looking at some of these. They have awesome examples. We've been to MDN before, kind of picking it apart. But what we need to know is that setInterval is a function. This is the version implemented in your browser, window.timers, but Node actually has setInterval as well. That's how we're going to use it. So here's its definition. It repeatedly calls a function or executes a code snippet with a fixed time delay between each call. Turns an interval ID. That's not going to be that important to us right now. So let's try to invoke it. So here it is. This is a built-in function. I'm going to invoke it. So I know that it needs 2 parameters. First thing, let's start with the second one. It needs a delay function. We could look here and see that delay is the number of milliseconds, pretty typical that computers are dealing in milliseconds, thousandths of a second, that the setInterval function should wait before each call. Okay, so I'm going to set it to 1,000 because that's 1 second. So the first parameter to this, it needs a function. All right, so let me write a function for it to take. I'm going to use the function keyword. And I'm just going to hit enter just to make this a little bit more readable. And I can do whatever I want inside this function. So I'm going to say console.log 1 second. Cool. This should look pretty standard. This is just a function that takes 2 parameters, and I've given it both of its parameters. The first one being a function, second one being this delay. So when I run this, we see it works. It logs out 1 second, 1 second, 1 second. In this situation, I've passed it. I've defined this function on the spot and passed it in as the first parameter. But we know that functions can be passed around just as values. For example, I could easily say set variable delay equal to 1,000. Let me quit this node function here. Clear that out. Right? I could pass in this variable delay, and we can all see that it's going to be doing the exact same thing, right? It's going to do a variable substitution, find this variable delay equal to 1,000, and this will work just like it did before. I can do this same thing with the function that I pass in to setInterval, right? I could say log 1 second equal to a function. You know what? I should open up my chat, because if there's any questions, we'll see it. Okay. Sorry, guys. I have this function, and all I want to do is the exact same thing, console.log 1 second. Now I can remove all of this code that I just wrote and pass in the variable that points to that function, right? I've saved this function as a variable, and now I'm passing that variable in place of this whole function. Oops, I misspelled function there. Did that work before? That's crazy. Oh, I didn't do it. And this should work just as it did before. 1 second, 1 second. Thumbs, we're clear so far? Passing functions to functions? Any questions? Any thumbs down? Anybody? You guys actually got into this a little bit, I realized, in one of the exercises because it asked you guys to look up use for each. How do you stop a program, Raymond? In this, you hit Control-C to stop node and then Escape to close your build window. So we're going to talk about for each later, but just recognize that similarity. The for each method executes a provided function once per array element. So it's a method on the array prototype, obviously, array.prototype for each. So you use your array that you've made, dot for each, same thing. Here's that function. Here they're calling it a callback. Callback, function to execute for each element. We're going to talk more about that later, but just realize similar thing is happening there. So what is the difference between this and this? Who can unmute and tell me what is going to happen if I hit run right now?
So log 1 second is going to return undefined since you didn't return anything. And then delay, I didn't check the syntax for set interval, so I don't know exactly what set interval is going to return itself. But log 1 second will return undefined, so that means I guess you will either get an error or you will get undefined for set interval.
Awesome. Evan's got it spot on. This is no longer a function that I'm passing in. It's a function invocation, right? So variable substitution is going to take place. This is going to execute. So actually, we will actually get a quick. This will execute very immediately. And then this will be replaced by undefined because this function has no return value. Set interval is not expecting undefined as its first parameter, right? It's expecting a function that it can execute multiple times. Do this actually. So here, let's run this. It runs this function once, right? It finds it, immediately invokes it. That's what these parentheses are doing. And we get 1 second logging out once, but then we break, right? Cannot read property call of undefined. That's how set interval is working under the hood. It's taking my function and turning it into another function it can call a lot. But anyway, it breaks. It's saying like, hey, this isn't what I asked for. Basically, this is undefined and I wanted a function. We can also see that this happened right away, right? Let me do this really quick. It's like 3 seconds. When I did not have these parentheses, and I have this now at 3 seconds, see, like we're waiting for this to happen. And then it happens 3 seconds later. Let's cancel this. When I pass this invocation in, it happens right away, right? This invocation gets invoked as soon as it hits it. And then the second time it tries to actually invoke, when set interval actually wants to run after this delay, after these 3 seconds, then it realizes that it was not passed a function and it cannot operate as it's expecting. Cool. We're going to talk now, we're going to switch and talk about functions, returning functions, and also about closure. Everybody ready to move on? Any questions at this point? Okay. Got this. So let's start by doing this. Function. It's gonna be just like a little bit of review. Let's do. And okay, so there shouldn't be anything new at this point. I have 4 console log. I'm going to comment this out. I have 4 console log statements here. When I run this, type in the chat, what 4 things are going to print to the console? This is not closure. This is just, okay, I've got 1, 2, 1, undefined. 1, 2, 1, undefined. Exactly. I'm going to get, I'll just run it. 1, 2, 1, and then mine just breaks. It says that it's not defined, right? And this is scope. We're inside this function log x and y. Remember, this creates its own little walled garden. It first this function is defined, and down here we run it and we jump back up. We say console log x. X looks around in its own little local scope, which is this function, and realizes I don't have an x. It can reach out that one-way door and see that x out here in the global scope is 1, and it logs it. It looks for y, it finds it in its local scope, it logs 2. Then we come down here to line 21, console log x. In its scope, it finds it 2, global scope, logs 1. But when it looks for y, it can't see it. It's inside this walled garden of this function log x and y. And it cannot reach in. It's just a one-way door. It doesn't let you reach in. People will describe this as like reaching into like the blender, right? Functions being like these little blenders that do things. The parent scope cannot reach into this blender. You can look outside of it and pull things in, but you cannot reach from the outside and get this. So, oops, crap. Hold on one second. Let me find some other code I want to pull up here. Okay, back to this. So closure uses scope. Closure is just functions that hold on to data. So let's say that here. Closures that hold on to data. So we're going to ditch this guy, this little scope guy, and write some new functions here. So here we have a function outer that declared a local variable a, and then inside outer declared another function inner. This function simply has its own local variable. It's going to console log a from the scope of outer, and also going to console log its own variable b, which lives in here. The last thing I'm going to do is invoke inner. So down here, I'm going to invoke outer. What's going to do here? Let's put a couple of console logs to make it clear where we are. Let's see. We'll actually put this somewhere else here. The way this executes will be easier if we have some console log statements to keep track of where we are. Let's say so when I run this, let's walk through the kind of execution here before we do it. The compiler is going to come down, see this function outer, realize this variable outer, not realize it's assigned to a function, move down here. The first thing we'll get is this console log statement about to invoke outer. And then outer is going to be invoked, which means we jump back up here to line 24. We go into this function body. Var A is 1. We see this inner. It's assigned to a function, so we skip over that for now. The next line we hit is line 33, about to invoke inner. And then on line 34, we invoke inner, which means we jump into this function, and we're going to console log A and B. Everybody clear on like kind of the series of events that's about to take place? Okay, so let's run it. About to invoke outer, about to invoke inner, 1, 2, just what we expected. Now, what I can do, as opposed to just invoking inner right here on line 34, I can return inner without invoking it, which means that the return value is going to be this entire function. So instead of about to invoke, let's say about to return inner. We'll call outer, and this time we're going to capture the return value of outer, which is going to be, right? Because we realize now that outer has a return value, and it's a function. It's this function that I just defined in here. So now I'm not getting anything printing. Well, I get these two things printing to the console, the about to invoke outer. Outer then gets invoked. We log this thing to the console, about to return inner, but I'm just returning this function. Here, okay. So return func is a function that I can invoke. So when I run this now, I'm going to finally invoke this function inner, right? Because it was returned to us from the invocation of outer. We invoked outer, it gave us this function, return func is a function. So later in my program, like wherever I want, I can invoke return func. And here we get those same variables, 1 and 2. This is where closure is happening. Closure, remember, is a function that holds on to data. This variable A was not in the scope of this function inner. It's in the scope of outer. Outer was invoked and returned right here on line 39. But 43 is retaining access to this variable because it had access when I wrote it. So closure is functions and that retain access to the scope they were written in, not where they're invoked, right? This could be many, many lines later. I could call return func, and it's still going to remember this var A and be able to log it. Questions? Anybody want to shout out any questions?
I have a question.
Yeah.
Can we look again at the console print, the order of the console printouts?
Yes.
I expected that the, let me see. Okay, about to invoke inner. Was the outer function, is outer function being invoked in this build?
Right on line 39 it is.
Oh, okay. All right. I was wondering where the console printout for that came from. Okay, thank you.
Yeah, no worries.
So if you created, so if you made two return func variables, like return func1 and return func2,
Yes.
and say if you passed in a variable to declare a on 25, instead of signing up to 1,
Like input?
yeah, and then you pass the function and input, would that, so if you did, yeah, something like that,
Let's see, who else can I see on my screen? Evan.
would it overwrite Nick the second time you ran it for both of the variables?
Let's find out. Oops, 2. What do you think's going to happen, Nick?
I have no idea.
Let's look at it together. So we have about to return inner. We have Nick, Evan, Nick, Evan. So when I invoke, every time I invoke this function outer, I create a new scope. So this variable, return func, its invocation of outer, it like has its own association to this variable, this input. Here's a way that maybe it would be easier to see it. Let's see, console log a plus plus. If I keep calling, let me comment these guys out. Wait, I gotta get rid of some of these other ones. What did I misspell it? About to invoke outer. Oops, I forgot to do this one. Assign it to the value here. I'm not going to pass it an input though. I have too many console log things in here to make it okay, because B is this. I'm going to ditch this variable. That's not really that important to us. That's obviously that function always has access to the variable that's inside of it. What's more interesting to us is that it's able to retain access to this variable and change it, right? Okay, so now here's what we see. 1, 2, 3, 4, 5. If I then assign another variable to another separate invocation of outer, let's put another console log to separate these two. What did I do wrong here?
There's a V at the bottom.
Oh, thanks. Right, so here I'm running return func the first time, 1, 2, 3, 4, 5. Obviously, I could keep invoking this anytime in the later in mine, and it would still remember its association with A, the current value that it left A at. When I declare a new variable and invoke outer again, I get a new context. So as I keep invoking this, it has its own association with A, and it's keeping track of its own value. So we start back over at 1 when I log it.
Cool, thanks.
If on line 58 you called return func, would it print out 6?
What do you think?
I don't know.
So let's say like log 6 question mark. Right? Because it's keeping track of its thing, its returned func. And it said, hey, the last time I was here, it was a value of 5. And now it's going to increment it and log it again. It doesn't matter what we do in the meantime. Return func2 and return func, they have like two opposite, they're keeping track of two different values of A. They each have their own A that they're incrementing.
So is it 2 different spaces of memory that that A is created on?
Yes, every function invocation creates its own new scope, execution context. So every time I invoke outer, it's creating like a new context, not related to its previous invocations.
Well, one question: why does it count? Because we're just console.logging it. Actually, we're not changing the variable, do we?
We do. A++ is actually an expression. It's like a mathematical expression that is actually incrementing it. So remember, like inside these parentheses, that gets turned into a result value before it actually gets console.logged.
So when you change a variable outside of a function, it usually clears what the variable is, or what the value of the variable is, and then if you imagine a variable as a box, you dump out the box and you put the new value inside of the box, right?
So how would we do that here? Like you saying that I would change the value of a...
I guess, I mean, I understand, I guess, like, that functions have their own scope, but I'm having a hard time, like, visualizing, or I guess understanding, like, how A can have two different values, like, if it's the same variable.
It is like a different variable every time we invoke outer. So every time I invoke a function, I create a new execution context, which kind of preserves its personal relationship with variables. So here I have outer, right? I've assigned this particular return value of outer, this invocation of outer, to this variable returned func. So it's keeping track of the status, the current status of what was going on its version of this function invocation. So it knows where it's leaving A. Well, it's returning inner, so it knows, it keeps track of this. The next time I invoke outer and assign it to a new variable, it's like creating a brand new context here that's keeping track of its own value of A. It's just the fact that every function invocation creates its own new context.
Lisa?
Okay.
Yeah, Ben? Is that Ben?
Mike?
Oh, Mike, go ahead.
For illustration purposes, would you run return func a few times next to outer?
Return func next to outer. So tell me where type. Should I clean some of this stuff up?
Yes.
Okay, so let's delete that. So far, all we have now is we have two separate invocations of outer saved to two different variables. And then what should I type? What do we want to see here?
So return func is going to hold on to the return of outer and continue to increment it. And when you call it a few times, we see that incrementation. Mm-hmm. But if we run the original outer again before it's getting a return to return func, it would probably be nice to see what it returns as opposed to return func.
Okay, so if I comment these out and I just invoke outer?
Well, after the assignment of return func outer,
yeah.
If we invoke return func, we've seen the variable. What happens when we go back to the original outer and see the output of that invocation? Yeah, just like that.
Sure. Is that what you expected? Actually, we have we have it running twice here, right? We have this console log about to invoke outer, and we invoke it, and then we invoke it again, but this time we save it to a variable, and then we invoke it again, but we don't capture its return value, right? Here we've invoked it 2 times, but we don't do anything with its return value. And until we capture its return value and run it, like we run return func down here, oops, we never actually enter into this function body, right? Because all I'm doing on line 34 is returning I'm never telling inner to run yet. Inner has never run until I invoke it on line 51. All that this function outer knows is that it is spitting back a value, and its value at this point happens to be a function. So I can capture that return value in a variable. And then if I said here, type of return func, let me get rid of some of these invocations here, just to clarify. That didn't.
Do we have to console log the type of?
Yes, thank you. Sometimes the node, I thought that would actually just do it. Let's do this. Console log type of. Thanks, Ben. Right? It's a function. So that means that it's like special, right? I can invoke it. So this is two things. This is a function that returns a function. And it's utilizing closure because it's retaining access to a variable that is not local to this function. It's retaining access to variables that it had access to when I wrote it, right? It wasn't a surprise to us that when I didn't return inner, but I just invoked it here. Like it was clear to us that, well, hey, yeah, of course, when I invoke inner, it's going to know what A and B is because A is right there. It's just going to go grab it. Closure makes it possible for us to pull that function out of, return that function, pull it out of the invocation of outer, and keep it indefinitely. We can keep returning, we can keep calling this returned func way later, long after outer. We may never call outer again, but we still have access to these variables that it created for us. So there's one thing I want to go over here, which is just like basically the recipe for closure, for creating closure. Closure is very useful to us. It enables us to like kind of keep track of these variables indefinitely, right? Like maybe this is something more complicated than a variable. And this function allows us to have this ongoing access to it. I'm going to pull up this slide deck I found, which is super awesome recipe for closure. So this is how we create closure. We create a parent function. Let's see if I can just split screen here and still have it on with this guy. Okay, here's our parent function. We called it outer. Input, we don't need input at this point. We defined some variables in the parent's local scope. We said var a equals 1. Define a function inside the parent function. We are calling this inner. Our inner function accesses variables from the parent scope. Then we return that function from inside the parent function. Here we go, we return inner. Well, I think there's one more slide in here that's pretty good. Okay, here's execution. We run this parent function. So here she's created it, right? Var scope, just using global scope there. Creates this parent function check scope. Has a local variable, var scope equals local scope. She creates a child function, inner function, that is going to access this, its parent's function, its parent's scope to pull out this variable. And then she returns the inner function. All right, she invokes the outer function, check scope, and captures its return value as test. Test is a function, right? If we said type of test, it's going to be a function. So when it's invoked, we get this function being invoked. It's going to return scope. What would log out here? Anybody? If this bit of code right here, and we invoked test, what is going to happen there?
Yeah, it would show scope of inner function.
Which would be what? Nick has it in chat too. It's a string, right? It's going to run this function, inner function, which returns scope, local scope. So we would get this string local scope returned to us. We'd actually have to like console log the return value of test, but it would give us access to this variable scope, which is assigned to the string local scope. This is a complex topic. Like I said, if this is the first time you've thought about closure, then don't be concerned. We will talk more about it and use it a little more. For this course, you won't actually be required to use much closure to make it work, but it's something, it's like, it's kind of an advanced JavaScript topic, but it's something to kind of start building your familiarity with. I'll post this code in Slack so that you guys can look at it a little more. We'll probably have like a little bit more in-depth discussions about it again, once it you kind of have a chance to like sink in and think about it a little bit. Like I said, this won't be mandatory. Closure is not something you'll necessarily have to deal with I think today there'll be some challenges that go along with it, but kind of think of this as starting to build familiarity with how closure works. No, Kevin, it's not an important topic for the HR immersive interview. But it's kind of one of those fundamentals that like will become important. And as you do it more, it will become more familiar to you. Remember just these key things, like this function retains access to the variables in the scope in which it was written. Not where it's invoked, but where it was written. Could we try console.log an invocation of outer? That would print the return value of outer, right? So what would that print then, Scott, if we were logging the return value of outer? I'll do that right here. Because what is the return value of outer?
Wouldn't it just be 1 and 2 and about to return inner?
That's the return value of outer is right here on line 34. It will invoke it. You're right. It will console log this about to return inner. Here, let's try this. Actually, let me put this here. So here I'm logging outer, and this tells me this is the actual body of the function, right? Because this is assigned to inner. So when I log out the return value of outer, I get this. I get this function. Let's see, the next part of your question was, would it also create a new scope for outer that would change var a on consequent console log outers? No, it wouldn't. I have to save this variable, save this invocation to a specific variable to reference that same context again.
Okay, great. Thanks.
So it would be the same if we console log, instead of invoking outer, we could just type the variable return func without using parentheses, and it would be the same, right?
Exactly.
Okay.
Because we just saved it. We saved that variable to that. We can do that here. Well, it just prints out this function, the word function at that point, but that would be the same thing. Okay, a lot of topics today. Expect the challenges today to be like a little sticky. Like some parts of it, it'll start, the challenges today, the prompts, they start back at the beginning of what we talked about, right? Passing functions to functions. As it gets further into it, it'll get a little trickier, and expect it to. Like reach out to Zan and I. This will be a time to like really ask us to come and like talk about what is going on and what we can help you. Give more examples and just walk through code. But don't hesitate to just open up Node and try things. Type stuff in and see what happens. Get a grasp for it. Further down, the two things at the end of today, this lecture was pretty long. It's going to talk about underscore. Just like arrays have a lot of built-in methods that we've used, like, well, we've used for each, we've used length. Of course, I can't think of any others off the top of my head right now. Underscore kind of implements even more functionality. This functional programming with underscore and this last re-implementing underscore is what we're going to spend a lot of our time on in the next 3 days, talking like very in-depth about. This part's just going to ask you to use this data structure, right? This is an array of objects. Look at the underscore library, understand what first, last, filter, reject is going to do, and then manipulate this data structure with those underscore methods to see how they are, how you can use them. So if you don't get through this part today, certainly I wouldn't expect you to get here. This, and this will be things that we will be dealing with for like the next 2 to 3 days. So start up at the top. This will kind of reiterate a lot of the stuff we just talked about in class, and ask us lots of questions. Any questions at this point?
What are the groups?
We're going to try using the breakout thing again to put you into pairs, because otherwise seem like we're kind of at a dead heat of whether we actually get you with a new pair or not.